In this video, we're going to talk about how to combine different logarithms. Alright, so when we were learning about exponentials, we learned all these different ways to combine exponentials. If you multiply two exponentials with the same base, you can actually just add their exponents. If you're dividing two exponentials, again, they have to have the same base, then you subtract their exponents. And if you have this kind of double exponent, that's when you multiply. Alright, so we have ways that if we have different kind of exponents working together, we can combine them into a simpler expression. And since exponents and logarithms are related, hopefully there's some way we can do this with logarithms as well. Alright, so here's our rules, and they're kind of the reverse of the exponent rules. Alright, so with the exponents, we multiplied the exponents and we ended up adding the exponents. For logarithms, if we add two logarithms together, then what we do is we smush them together into a single log where we multiply. So it's kind of the opposite of this rule. Here we're multiplying and then we add. Here we're adding and then we multiply. All right, the next one is just the opposite. So if I subtract instead of add, I'm going to divide instead of multiply. And again, that's the opposite of this one. Division leads to subtraction. For logs, subtraction leads to division. And this one isn't quite as obvious how it's related to the exponential stuff. I have this one. If you have a number in front of a logarithm, you can take that number and it's going to jump inside and it's become an exponent. So this one might be the hardest one to do just because it doesn't directly relate to an exponential one. But this is very useful. All right, numbers inside can go out. Also, we can do these things backwards as b can kind of jump out to the front. All right, so these, just write them down for now. All right, over time, you're going to have kind of them memorized, but you'll use them in practice and get used to them. All right, so these are the types of questions we're focused on in this lesson. All right, we have these two different logs, and we're going to kind of combine them into a single log. So we just saw in our rules that when you add two logarithms, as I double check that they have the same base, that's important, but they're going to kind of smush together into a single log with the same base. And then inside of that, I take these two insides and I multiply them. All right, so now I can smush these together into a single log, and that's my final answer. All right, what about a log like this? All right, again, they're all the same base, so that's important. When I'm doing my rules, let's go back to those real quick. I just have to have a single log. There can't be any numbers. So the first thing I have to do when I'm trying to combine logs is get rid of those numbers at the front. But I can do that by just popping them into the exponent. So if we go back to this example, all right, this 4 here, it's going to jump into the exponent there. And this 9 here is going to jump into the exponent there. So I'm going to rewrite this as log base 8 of a to the 4th minus log base 8 of b to the 9th. All right, so those numbers can just jump into the exponents. And now we just have this single log here, this single log here with a subtraction sign. And our rule says that this, again, smushes together into one single log. And then what's on the inside, we take the first one and we divide it by the second one. So that's the process. Put those numbers in first, and then you can do the combination after that. All right, so summary, we're going to do some more examples. You can bring any numbers in front of the log. Inside is an exponent, so the first thing I would do. All right, when logs are being added, you can bind the insides and multiply. Probably add that and multiply. When logs are being subtracted, you divide the insides. All right, so problems are going to start getting a little more complicated just because there'll be more terms than just 2, but all the rules still apply. All right, the first thing I would always do is take these numbers and bring them in. And then I can only combine 2 logs at a time using my rules. So I can combine these first two. I see there's a minus sign between them. So just like our last example, we can combine those into a single log. We take the first term and we divide it by the second term. All right, and this term we haven't touched yet. And now we just have these 2 logs with a plus sign between them. And then we're going to smush those together into a single log. We take the first term, and because there's a plus sign, we multiply by the second term. And then finally, we just write it a little bit nicer. Because this is over 1, I can put these together on the top of one fraction, like that. So this is the answer. All right, so you just want to kind of work left to right, combining 2 logs at a time until you've gotten one single log. All right, so here's another example. Again, hopefully you see the first thing. I want to get rid of these numbers at the front. So to do that, I'm going to have log of a to the 4th minus log of b to the 8th minus log of c squared. And now I just have the logs, but there's a minus sign between these first two, so I can divide them. And now I have a minus sign between these two, so I can take the first term and divide it by the second term. And this is not fully simplified. Generally, we don't like having fractions within fractions. So how do we simplify this? We have a to the 4th over b to the 8th divided by c squared. We can do keep, change, flip. So this division changes the multiplication, and c squared turns into 1 over c squared. So keep the first one, change, flip this to a fraction, and we get a to the 4th over b to the 8th c squared. So that's going to be our final inside. And here's where we can see a little bit of a shortcut. So this is generally what's happening, but generally I will go from here down to the answer. And the way I do that is if something is positive in this step, when it's just all the single logs together, if something is positive in this step, it's going to end up on the top of the fraction. If something is negative in this step, it's going to end up on the bottom of the fraction. So I can go from here to here by just knowing positive things end up on the top of my log fractions, negative things end up on the bottom of my log fraction. So I can save you a little bit of time, but also this is what's happening in the middle. All right, so go ahead and try this one on your own. All right, simplify until you get a single logarithm. All right, I'll show you the answer in 3, 2, 1. And here's the answer that I come up with. So when I have these single logs, I take all these numbers and put them in as exponents using that rule. And then these two terms are positive. So the x to the 12th and y cubed are going to end up on the top of my fraction. And then this term is negative. So the thing on the end of that z squared is going to end up on the bottom of the fraction. All right, so that's the way you can save yourself a little bit of time rather than going through every single individual step. All right, so now, all right, you're free to go if you kind of understand. Here's some challenging problems, that kind of little extra things you might have to be aware of, whether it's different types of exponents, little tricks with negative signs. So if you want to see a couple more types of problems, stick around. If you're kind of comfortable with what you've seen already, all right, go ahead and practice and you can do the skill check. All right, but I'm going to go through this problem now. So the big thing here is we have this set of parentheses here with this -4 in front. So you have to make sure to distribute this -4 into both of these. All right, so our first step's not actually doing anything with the logs, which is why this one's kind of a challenge problem. And now that we have it written kind of similar to our previous examples, now we can put the exponents in. Oops. And now that we have all the single logs without numbers up front, I can combine them. We get x to the 1/2 over, this is a -1, so it's going to be y to the 4th. This is also a -1, that's z to the 4th. And that's perfectly fine, but here's a couple other ways you could write it. One other way you could write it is x to the 1/2. We know that's the square root of x. That's generally the way you would see it if someone was writing like a solution for this. Another thing is these both have a 4 exponent, so one way you might see someone write it is like this. Y and z are both being raised to the 4th. So I would think if you were seeing this in a textbook and you were like looking at the answers in the back of the book, I'm pretty sure you would see it like this is the final answer. All right, what I would expect kind of on a skill check is probably this middle one. You remember that the 1/2 is the square root, and you can kind of leave these separately. But either one of these I think is fine. All right, second challenge problem. All right, now there's just some x's involved. There's all these different x's. What's going to change? Well, nothing's really going to change at the beginning. I'm going to bring my numbers in. All right, here's where a notation thing might happen. You might write 4x squared. All right, that's not actually what's happening. Because the way I write it like this, that means the squared's only being done to the x. But when the squared comes in, it should go to the whole inside. So I want to do 4x. And that's all squared. So I need actually a little set of parentheses, and then minus log of 8x to the 5th. Now I can combine. This is all 1 log x to the 5th times 4x squared. I'm going to get the x squared, but also the 4 is getting squared. That's going to be 16x squared over 8x to the 5th. And the main reason this is a challenge problem is, one, that part of remembering to square both of these when this 2 goes in. The other thing is now I can simplify inside of here a bit. I have our logarithm, so our exponential rules. I can combine this into 16x to the 7th over 8x to the 5th. And I can combine these as well. I'm going to get log of 2x squared. All right, so this one's a challenge problem just because there's more simplifying you can do. You have to be careful in this first step, and then you can simplify the inside to something much simpler. All right, so there's just some extra types of problems, not the ones that will be on the skill check, but they're ones that you technically should be able to do if you just think about them and take your time. All right, just remember the log rules are the opposite of the exponential rules, and always bring in those exponents before you start combining. So if I try to go all the way back to here, you can't have anything in front of your logs when you're doing these combining steps. So you always have to figure out how do you get rid of these numbers at the front, and the answer is just bring them inside. All right, so make sure to do that first, and you'll be fine with doing your log combinations.